Hey, how you doing? Well, if you're seeing this, it's probably because you didn't do too good on your lab experimental report, second part of our test for chapter 1. So, watching this video and then answer some questions, we're going to see what we can do about that grade, maybe beef it up a little bit. So good luck, and I hope you learned something. If you have any questions, make sure you ask me in class. Alright, I'll pause it here and get it going. Okay, experimental lab report, a remediation video. Okay, first thing we have to start out with on our lab report is a title. A title communicates what your experiment is about. It has to be specific. So a good way to format the title is the effect of, state your independent variable on your dependent variable. Again, the independent variable is what you're changing. So in the plant experiment, if it was the light, you should say the effect of increasing the light on the plant, but what are you measuring about the plant? So if you're measuring its growth in height, you would say growth in height. Or if you're measuring the mass of the plant, you could say mass of the plant. So the effect of increasing the light on the effect of increasing the light on the mass of a bean plant. That's a great title. Let's go on to the next section. The next section is purpose question. You write a question for the investigation. Write this in either a question form or a purpose form. It should have the following components. It has to be specific, covering only one general thought, and it should be able to be investigated. A good example. The purpose of this investigation is to determine how temperature of a stream affects the amount of oxygen dissolved in that stream. An example that's not so good is, how does temperature affect oxygen? Because it's not really telling me what you're doing on that experiment. So, for the plant, you could say, the purpose of this investigation is to see if by increasing the light that the bean plant will grow higher, as measured in centimeters. That would be a great purpose or question. The hypothesis is to develop a claim or prediction. It has to be expressible, cause and effect. It has to be testable, because that's why we're doing the experiment. And it's based on prior knowledge, not a wild guess. And, boys and girls, the hypothesis comes before you do the experiment. You don't change your hypothesis to fit the data. Okay? You do the hypothesis, and then you run the experiment to see if your hypothesis is true or if it's not true. If your experiment proves your hypothesis, great. If your experiment disproves your hypothesis, it's equally great. Because that's why you're doing the experiment, to see if your hypothesis is true. So if I increase the amount of light, then the plant height will decrease, as measured in centimeters. Great hypothesis. Now I can make my experiment to do that. Experimental design components. Independent variable, also called the manipulated variable. This variable, you change the manipulated variable to determine how it affects the variable you measure, which is going to be the dependent variable. And when you're making a graph, it's always on the x-axis. Okay, so what I just said. Okay, the independent variable is what you're changing. So in that example I've been using about the light, the amount of light, or increasing the light, okay, will be the independent variable. Okay, so that's what I'm changing. You only change one variable. If I change how much light and how much water, then I really don't know what's making the connection with the plant and get it to grow higher or lower. So I want to limit the independent variable to one variable only. Then we get the dependent variable. The variable that responds, also called a responding variable. The variable you measure. That's the key word. You're going to measure this. How are you going to measure your dependent variable? Well, the effect of the action you took it's always placed on the y variable. So our independent variable is on the x. Our dependent variable is always on the y. So in our plant, the dependent variable could be the height of the plant as measured in centimeters. Or it could be the mass of the plant as measured in grams. Either way, you can measure something. Okay, it's something you can measure about the growth of the plant. Then we have our constants. These are all the other variables that remain the same for all the trials. So continue with the sample that I've been giving you. A constant could be the soil, the water, the amount of light, the type of pot. So those are all constants. Those are things that are going to be the same across the board. Which brings us to our control or control group, a level that does not contain an independent variable. So you could cause your independent variable, if you're doing the water, let's say I want to see it's increasing water, the effect of increasing water on the height of a plant. So I could make my control group 50 milliliters, and then I would increase from that to maybe 70 and then 90. So I'm going to compare the plant with 70 milliliters of water to the 50 and the plant with 90 milliliters of water to the 50 and see if increasing the water helps the plant grow more. So that'll be my control group, the group that I don't change. If you were using the compost and the fertilizer, the control group might have been the plant without any soil amendments. That would make sense to me. Now the materials list. You have to be descriptive. You have to tell me everything. Okay? You can't just tell me plant pots and seeds, because you're going to need soil. You're going to need water. You're going to need lights. If your experiment had fertilizer and compost, you need to add those things. So everything you need to do that experiment. And then your procedures. Write a detailed and precise procedure that includes both the correct sequence of steps to be taken and the materials and equipment needed. So you can't just tell me change the number of lights. You need to tell me how many lights each plant is getting and what step that is in your procedures. I have to be able to read your procedures and repeat your experiment. So after you're done writing your procedures, you should go through them in your head. Okay, if I do this step, this step, this step, and by the end, you should be able to redo your experiment. That's what goes into the procedures part of your lab report. And then here's your data. Your data is going to be your tables, your graphs, your calculations. If you have drawings, it could be drawings. Now remember, if you're doing a graph, the independent variable is on the x and the dependent's on the y. You can see a sample there on the left of the independent and dependent variable as a sample table. If you have one independent variable and you have different trials and dependent variable units, then you can do it like table 2, that's a complex table. Either one will work. Okay, so this is just your data. You're collecting your data. Then results, you're going to tell me about your data. The results section is a section of text, paragraph form that describes your data and any patterns or trends the reader in an unbiased way. In your results, you have to refer to the graph or table and describe what it shows. You need to give me some values from your data. So if your plant grew 9.3 inches in 50 days, you need to tell me, 9.3 centimeters, 9.3 centimeters in 50 days. You have to give me something. Use appropriate terms to describe any trends. Did all the plants grow, but one grew more than the other? Describe the accuracy of your data. Explain to the reader how accurate data is based on the spread of the data. So, did you run the test 3 times, and out of the 3 times, 2 were really close and 1 was way out to lunch? Maybe it was, maybe that was just an outlier. It just didn't work right. Maybe you need to run that experiment a few more times to see if it comes out. But the key thing I was looking for is that your results referred back to your data, and you used your data, and you referred to the tables, that your data supported your results, and vice versa. Then we get to conclusion. This is a really, really important aspect of your lab report, because you're going to develop a conclusion for your investigation. The conclusions should contain clear thoughts and proper vocabulary. This section focuses on the answer to your question. It usually contains a description of the purpose of the experiment, a discussion, explanation for your major findings, and recommendations for further study. It should support or not support the hypothesis by using logical reasoning and evidence from the data. This should be in paragraph form. It's going to actually be 2 paragraphs. In the first paragraph, you restate the purpose of the experiment, right from the top of your lab report. Then restate the hypothesis. Already, if you spent time writing a good hypothesis, just restate the hypothesis. Then you're going to say, did your data support the hypothesis, or did your data not support the hypothesis? Either one is the same amount of correctness. Either one is great. You're just trying to answer, did my hypothesis, was it correct, or was it not correct? So you don't go back and rewrite your hypothesis because your data didn't support it at this point. Describe specific data examples or trends discuss possible scientific explanations of why the data came out that way. In other words, explain why one variable affected the other and why the trend occurred or did not occur. Use vocabulary concepts from your textbook or other logical ideas, but don't guess in this section. You got to use your data to support everything you say. In the second paragraph, describe any sources of error in the experiment and how it affected the results. Describe recommendations for improving the experiment. Be specific. Do not say, we should have timed or measured better. Be specific. We could get a better watch, or we need to be able to start the time blank, or we need to, instead of, if you ran your experiment 10 days, maybe that wasn't enough time for the plants to grow, so maybe you needed to go 50 days. Describe the recommendations for further study. So, in other words, if there was a big difference between the amount of water and you were changing the water by 30 milliliters for each plant, maybe change it by 15 and see if that makes any difference. So I hope this helps. Let's just do a quick review because I got a couple more minutes of things that I found. Okay, in the title, a lot of titles were not specific. The effect of light on plants. You're not really telling me what you're measuring with the plants. Okay, so you really have to be specific of what your independent and dependent variable are. Purpose in question, it was the same thing as the title. It just wasn't specific enough. So if you lost points on this, it's probably because it wasn't specific enough or didn't really tell me what you were doing in the experiment. And the hypothesis. Keep it simple. Follow the form. If I increase or decrease the independent variable, what you're changing, then the dependent variable, what you're measuring, will increase, decrease, or stay the same. Keep it simple. You're going to do a great job next time. Design, I think you guys, again, specifics on independent variable and narrowing it down just to one. Okay, if you had two independent variables, that I took some points because that's not right. Okay, dependent variables, what you're measuring, even better, how you're going to measure it. Plant height in centimeters, plant mass in grams. Awesome. Constants, a lot of people got lazy on this and only put one constant when there are definitely more. If you're keeping the soil the same for all, that's a constant. Control group, some just said pot A, but you really didn't tell me what pot A was, and I need to know which plant are you comparing it to and why. So pot A, because it's 50 milliliters, and that's what I'm going to compare the other two to. Procedures, I read your procedures. If I could do your experiment, you got full credit for that. If not, you might have lost some points. Your data, pretty much if you had your tables and your graphs, I gave you credit for that section. Results, if you did not refer back to your data, then you lost some points for results. And conclusion, you basically just have to follow the two paragraphs and the template and what elements are in those two paragraphs, and you would have got credit. So if you didn't have your hypothesis, if you didn't tell me you supported our hypothesis, if you didn't tell me any possible errors or reasons to do further experiments, then you might have lost a point or two in that section. So I hope this video helps, and I hope you do a great job on the questions following in the form, and we'll see what we can do about that grade and get it up a little bit. So this is Mr. McClellan, and I'm going to try to just pop up and just say hi, and good luck. All right? All right.